Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2522. Partition string into substrings with values at most key. In this video, we are going to explain a method or solution format based on linear traversal and a check condition. First, I'll read through the problem statement to digest the requirements, and then we do the analysis, and finally we explain the code. First, let's look at the problem statement. We are given a string S consisting of digits from 1 to 9 and an integer k. Notice that the digits are from 1 to 9. In other words, there's no zeros. So a partition of a string S is called good if first, each digit of S is part of exactly one substring. Secondly, the value of each substring is less than or equal to k. So we are required to return the minimum number of substrings in a good partition of S. If no good partition of S exists, return -1. So here are some notes. First, the value of a string is its result when interpreted as an integer. So for example, the value of the numerical string 1, 2, 3 is 123. So similarly, the string consisting of one digit 1 is 1. A substring is a contiguous sequence of characters within a string. So this part explains the interpretation. So here are two examples. So in example 1, so actually the k is 60, so we can have 16, 54, and 6, and 2. So overall, there exists a good partition, and the number of substrings in this partition is 4. So in example 2, so the output is -1. In other words, there's no good partition for this string and given k. So here k equals 5, but if we check the digit 8, so 8 is greater than 5, right? So therefore, there's no good partition. So before we look at the analysis, let's look at the constraints also. First, the string is not empty and its length is bounded above by 10 to the power 5. And Si is a digit from 1 to 9 in string format. Notice that 0 is not included. Secondly, k is greater than or equal to 1 and less than or equal to 10 to the power 9. So with that said, we are ready to do the analysis. So here, actually, we just need to use a for loop to do the linear traversal and check the value inequality. In other words, the less than or equal condition in the second item in the definition of good partition. So here, the point to be noticed is that so we need to pay attention to the end of index check and also the no good partition condition or case. So here we are going to use two examples given in the main statement to fix the idea. So when we check the we're going to check the numbers. When we check number n, we do update like n times n equals n times 10 plus the current digit, right? So if we see 1, so this is the 1. If we see 16, so it's 1 times 10 plus 6, right? So if we see 5, that is 16 times 10 plus 5, right? So let's walk through the two examples to fix the idea. So for example 1, here is the S and the K is 60. So when we see the first two digits, we have 16. So still less than 60, right? So when we see next 5, we're going to have 16 times 10 plus 5. That is 165, which is larger than 60. And therefore, we should stop before this 5. So we have 16. And then we reset. We are going to increment the counting of the substrings, the number of substrings in a potential good partition by 1. And then reset this n to be 5, meaning that we start from this digit again, right? So then we see the next 4, right? Then the corresponding number is 5 times 10 plus 4, that is 54, which is still less than 60. Then we see next 6, And then we do 54 times 10 plus 6, that is 500 something. It's greater than 60. So we need to stop, and we will have 54. And then we increment the counting by 1 for the number of substrings in the potential good partition. For now we do not know yet if there is a good partition. So now we set this n to be 6, and then we have 2, right? So if we check 6 times 10 plus 2, which is strictly larger than 60, so we need to increment the counting by 1 and reset n equals 2. In other words, we have a 6, right? So notice that as 2 corresponds to the end index, so we need to do a check if n is less than or equal to k, right? And if so, we are going to increment the counting by 1. And also, because of this the end, if this passes the check, it means that there indeed exists a good partition. If n is greater than k, it would mean that there's no valid good partition. We're going to return -1 immediately. So this can be seen in example 2, right? In example 2, k equals 5. So let's do it quickly because we have walked through example 1. So we will have 2 and 3, right? And then we look at h, because h is greater than 5, so we immediately return -1 as in the end part of example 1 here, right? For the check here for the check, and also this note. So with that said, we are ready to write the code. So here, actually, what we do is just to translate the above analysis into code format. So first, let me make some preparations. So here, step 1, preparation. So we're going to initialize a result variable, which is to count the number of substrings in a potential good partition. In other words, if a good partition exists. So meanwhile, we're going to initialize a number n, right? When we look forward, we're going to amplify this number by 10 and then add the current number and compare with the given key. So this is the initialization or preparation. So next, we're going to do the for loop. And condition check. So here we're going to check inequality, that is no larger than k, right? So for this, because we're going to check if we are at the end of this iteration, so we're going to use index. So as such, we're going to use enumerate, right? Enumerate s, and then the current digit will be integer of y, right? And then we look at the current number, that will be n equals n times 10 plus the current number digit. So first, we're going to check if n is less than or equal to k. If this is the case, so we need to pay attention. Typically, we need to move forward, but we need to consider if this is the end index, right? If I equals length s minus 1. So actually, you can also introduce a variable called length s, but it's not necessary. So if this is the case, we're going to increment the counting by 1. So we want to return result if there exists a good partition. So let me make some remark. So this is the end of index check, right? So with that said, so we're going to look at the else block. So if n is greater than k, so we need to stop. So first we need to count the potential substring numbers by 1, and then we reset this n to be current. So now we need to pay attention to check no good partition check. So in this case, if n itself is greater than k, so we immediately return -1. So right. So and then if it passes this condition, also we need to do end index case check, right? So as above. So if I equals length s minus 1, so we're going to do this. And finally, we can do the return. So let's call it step 3, return. So we're going to return result. So if there is no good partition, -1 is already returned. So this is a solution format for this problem. So I guess up to now, it's good to first do some check. Yeah, this passes the second example. Now let's look at the first example. So I'm going to change this to be here, and the k is 60. And it returns us 4. So now let's look at the generic case. Yeah, it passes all the generic cases. So that's about it for this specific problem. As we mentioned here, so we used the length s twice. So here maybe we can, for example, introduce this variable, the length of s, and we just write here length, and then do the check again. So yeah, it also passes all the cases, right? Because it's the same code, but it's a little bit neat, right? So with that said, I guess that's about it for this specific problem. And here we provided a specific solution format. So you are welcome to modify and come up with other solution formats, or even other completely different solutions. So with that said, that's it. Thank you.